just real quick, this is our Precal12 review. We're going to go into part 1 today. We'll start on unit 1, and then we'll just start answering questions going forward, okay? So we'll throw them out there, and then we'll get them rolling, all right? All right, so unit 1, what are you thinking? Is there a number that we can go over?
I just had like a quick question about number 4. I know like the equation, but how do you solve for the unit price?
Yeah, so first off, we know that, and I know you know, but just so in case everybody else doesn't know, we'll say RP equals -1/2 x squared, where x is p, right? Same thing, plus 1900 x. And then it says, what is the unit price when the revenue is 200,100, right? Where does 200,100 go in for? RP, right? So we're going to make that 200,100 equals -1/2 x squared plus 1900x. So what are we going to try to solve for in this case? What's up, JT? What are we going to try to solve for in this example? X, right? The unit price. So if we can figure out what we can do to solve for x, that's really the key. So we're going to subtract 200,100, okay? And if at any point y'all have a question, let me know. Please let me know. So we have 0 equals all of this here. Now, does anyone know what we could do on this to solve for x? Perfect. We could plug it in the calculator, right? Now, you could use like quadratic formula, something like that, but that would be unnecessary, right? So when you graph this, when you solve for this, the graph will look something like this. Now, it's a bad sketch, but that's kind of the idea, okay? The big thing we got to know is what x-intercept would we use on this? The left one or the right one? Why the right one, JT? Because it's positive. Very good. And we can't use the left one because that's negative. We can't have a negative unit price, correct? I mean, you can, but you're not going to be in business long, right? So we're going to use the one on the right. So if you go to your calculator, you kind of plug that in. You'll do left bound, right bound. Okay, so you'll go left. Once I graph this, you want to make sure too your window captures the whole picture. That's really a big deal. Okay, so when I come here, I can go left bound, right bound, and then I can guess right on top of that 0 to solve to see if I can find what that unit price would be there. All right. Is there anyone struggling with that, finding it on your calculator there?
Yeah, kind of.
Kind of, sort of? Okay. It's kind of high, isn't it?
Yeah, like, this is what I'm getting.
In fact, I actually drew that wrong, I think. That is actually going to be okay, because all we're doing, basically this is actually a wrong picture. I thought it was that picture, but as I back up, it's a little different. It's actually going to look something like this, like that. Does that make sense? So, Kaylin, right now, you are looking at like that right there. Does that make sense? So if we can just find this one way out here, that's going to be way too far. Okay, still a 0, still a solution, but we want to get this one right in there. Okay. So can we go left bound, right bound guess on that?
It's the 0, right?
Correct.
You just do any point over there?
Yeah, remember left bound, right bound. Left bound's below the x-axis.
Oh, okay.
Right bound's above, and then you can guess right on top of it. Okay?
I got 108.4.
108.4. Good. So $108.40 would be that unit price on that. Okay? So again, here's the big thing. Those of you at home, if you have questions with this graphing calculator thing, it's really hard for me to do it right here. I know, for instance, individuals in this room right now, I can help them out. Come and see me before the exam, and we can look at that, okay? But this should be $108.40 on that, okay? Again, that's number 1, unit 1, number 4.
Yes.
Awesome.
Yes.
And also make sure on there, I kind of see here, make sure you identify which ones are calculator or non-calculator. You also can bring in, like if you're not using the TI, you can bring in a little scientific one, okay? And I would bring one in because there's never enough in our classroom to supply for everybody. So bring one in if you have one, or borrow one from someone for that day. Under classroom, you could do too. All right? All right, you want to stay on Unit 1? Just kind of go through. Any other questions on Unit 1?
Number 1.
Number 1, perfect, yeah. So, all right, so on number 1, it talks about this projectile, right? It's 200 feet high, and obviously we're going to use our graphing calculator, kind of the same idea, all right? So let's talk through the different components, okay? So there's this 200-foot cliff, and all of a sudden we decide to throw something off that cliff, all right? Follows that projection. So we're given the equation that you see there. Now the first question says, how far from the base of the cliff is the height of the projectile, okay? So talk to me about that. Does anyone know what that would mean for this problem? Yeah, so we're really finding the maximum, right? So if we can find the height of this, that's the maximum. But what does A talk about? Specifically, what is A asking for?
How far is the cliff from the maximum?
Bingo, it's our X, right?
Yeah.
So really, if I were to draw this, it's really, we're trying to solve for what X is, right there, okay? The distance away from the cliff, all right? Do you know how to find the maximum there, JJ?
Yeah.
Okay, so remember, go to second trace, go to maximum, and then we'll go left bound, right bound, and then guess on top of it. Does that make sense? Okay. And that's how we would do it there. Okay. What does B ask for?
Maximum height.
So what would that be?
So the Y.
The Y, exactly. So that would be part 1 and 2. Okay. Do you need me to go into more depth on that? It's hard for me without a calculator to show you.
No, I got it.
Does that make sense? I would, while we're going through a problem, maybe you understand, go back to it, and if you have questions, let me know. Okay?
Yeah.
The next one, C, says how far from the base of the cliff will the projectile strike the ground? Someone talk to me about that. What is that?
Round is like the X-axis of the other side.
Good, yeah, so the X-axis is the water, right? So where it hits the X-axis, that will be the, that's C, right? So we could do the same thing we did in number 4 is the same thing we do here. So go to the 0, second trace, left bound, right bound, and then guess right on top of it. Okay? All right. D, when the height of the projectile is 100 feet above the water, how far is it from the cliff? Did anybody struggle with that one? The D part?
No.
Y'all understand that?
Yeah.
How do y'all do it?
I just plug like 100 in to the equation.
Mm-hmm.
Yeah.
Plug 100 in for what? X or Y?
Y.
No, I add it. Or I just like.
Could I show you something? Could I show you something here to make it easier on you?
Okay.
I'm going to show you something. I never taught it this way. Okay? I taught it a different way. I did exactly what y'all both said. 100 feet, right? Does that make sense? In your calculator, you can put, for Y1, you can put the equation that you see up here. Okay? For Y2, if you put in however tall you want it to be, let's say 100, okay? And press enter. In this graph, you're going to get a line that goes straight across. Okay?
Yeah. That's what I mean.
What can I do to find how far away from the base of the cliff the ball or whatever we're throwing off is 100 feet?
You can take the intersection.
Bingo. The intersection of that point from the quadratic and that line will get you exactly what we're looking for. Does that make sense? Does anyone have questions on that?
Yeah, I can't remember how I plugged that line in the equation.
Oh, 100, you're saying?
Yeah.
Go to y equals, and then just go down and put 100 in there.
I did.
You did? Okay, let me check that. Gotcha. Right now, you're right here. You're focused right here. So the line up is above
Yeah.
you. Can you go to zoom fit? You tried that?
I tried that. That's what I could say.
So stay same thing there.
Mhm.
Do this. If that ever happens, go to your window, and we know this is 200 feet tall, right? Okay. So you can make your minimum like -10 for the Y, and then your maximum you can make like 210. Make sure it's a little bit larger for your Y we're talking.
Yeah, that works.
And then did that help that?
Why- Oh, there we go. Yeah, now it's there.
And then hit that second one. Perfect. That's all you need. And so that intersection right here, that's what you would have to find. Okay. Now, do you see how like a drawing like this, how that would help? You see what I'm saying? Like if I looked at this drawing, what I could do is I could say, all right, Chloe, you can see him. You could look at this and think, oh, okay. I know that if I'm getting a picture that's in the fourth quadrant, I just need to move that up a little bit.
Yeah.
And then you can get it there. Okay. Really, these problems aren't hard. The only part that's really difficult is the calculator. Trying to get the picture that you're looking for. 9 times out of 10, though, you're going to be in the first quadrant that you're looking at, so you can adjust that accordingly. Okay? All right, so any questions on one? Is everyone good on that? Okay, those two are probably the two that I'm nervous about. I'm not really nervous, but ones that focus in on, so that's great that y'all are good there with those. Any other ones with Unit 1?
We do 9.
Yeah, absolutely. Oh, X and Y intercepts?
Actually, I think I only had a question on the x-intercept.
Okay. Does everyone know how to find the y-intercept?
Just plug 0 for X.
Perfect. Good, Caitlin. Plug 0 for x. So are we good on that one then? We'll just do the y-intercept? Or the x-intercept, I'm sorry.
Yeah.
So would the y-intercept just be 5? Or when you plug in 0 for X? Is it
Okay, so 0 in for x. That means that this would be 0 plus 3, which would be
3?
square that
No.
times -4.
Okay.
You see what I'm saying? So if it was in standard form, you'd be right, because it would be whatever the number by itself is. Okay? So now in this case, we're going to plug 0 in for y to solve for what? X-intercepts. Good. Yeah, good, JT. So how do I solve for that? Subtract 5. Good. Then what can I do? Good. Divide by -4. If I go too quick, let me know. Okay? Slow me down. This is for y'all, so let me know. So what do I get on the left side? Good. 5/4 equals x plus 3 squared. So how do I solve for x? Square root both sides. Good. So the square root of 5/4 equals x plus 3. What am I missing on that? A lot of people will miss this on the test. Okay, this could be square root of 5/2. I like that. What else am I missing?
Oh, yeah, sure.
Okay, I could subtract 3. Good. But I'm still missing something.
Plus or minus.
There you go. Plus or minus that. The square root of 5/2. Be careful on that. So you got to have this plus or minus. So that would be sufficient. -3 plus or minus square root of 5. And the square root of 5 is over 2. You could leave it just like this. Okay? Don't do this, though, because this is really technically not right. Why is that not right?
Because it's not like there's no 3.
Good, Caitlin. So we just leave that as is. Okay. So y'all said you were good on the y-intercept, right? We're good there? Okay. And this would be comma 0, right? It's the x-intercept. All right. Any other ones on Unit 1 that you see? Stephanie, did you find the formula sheet online?
I didn't look.
Okay. Let's look in here. I think the formula sheet I put online, let me check this out real quick. See if we got it here. I believe I put it on the top page, maybe not. Maybe not here. I thought I did. If not, what we can do, let me look and see. Remind me over there and I can get you one. Oh, yeah, it is. It's right here. Let me make sure that that's right. I'm going to actually pull this one up. I think it's on the introduction page of Haiku, but I want to make sure it's not the one from last year. Oh, yeah. This one actually, let me make sure of this. I believe that's the same one. I think that I might even tweak that one there. I might have tweaked that one, JT, so we can look at that later just to make sure, okay? All right. Any other ones on Unit 1? Is everyone good on Unit 1 there? We're all good? Okay, perfect. Let's go to Unit 2. Just keep rocking. Any ones on Unit 2 you want me to look at?
When you graph holes again, do you just put the circle in the little, and then you just keep on going?
Yeah, do you know how to find the equation of a hole? Does that make sense? Like when I say equation, I mean the x and the y.
Oh yeah, you do.
Yeah.
It's like you solve for the x by doing the thing, and then y you just put it back in to what's left.
Yeah, absolutely. Do you want me to look at one like number 1? Would that help y'all?
Yeah.
Would that be okay? Okay.
Yeah.
All right, plus 2x. Although x squared plus 8x plus 15. All right, what's my first step when I find like asymptotes, holes, all that stuff?
Factor.
Yeah, let's factor it, right? So what would the bottom factor into? Good, x plus 5, x plus 3. Good. What about the top? Good, take out an x, and we're left with?
X plus 5, x minus 3.
X plus 5, x minus 3. Is there anyone who has troubles with that at all? Is everyone okay? All right, so for me, what I do, every time I get one of these, even for myself, I list out VA, HA, and hole. I just list it there. The reason why I do that is just to set myself up so I know exactly what I'm looking for. And I don't think there's anything else. Yep, that's it. Okay. So what do we do next? Cancel. Yeah, what can we cancel, Caleb? Good. And what does that tell me?
That's the hole.
Good. Yeah, so the hole is going to be at -5. How do I find the y value of that, of this one?
You take that -5 and put it back into equation.
Good. The whole thing or the
Just
simplified one? Good. Simplified one. Because if not, you'll get 0 over 0, right? Because of these two. So we get -5 times -5 minus 3 all over -5 plus 3. So what is -5 minus 3? -8, right? -8 times -5? 40 divided by, what's this?
2.
-2, right? 40 divided by -2 is -20, right? Does everyone see what I did there to find the y of that? Okay, so if you were graphing it, Stephanie, you could go straight to -5 and -20 after you graph it and just put a hole right there. Okay? What would be the vertical asymptote?
That'd be the bottom.
The bottom set equal to 0, which would be -3. Good. So this would be x equals -3. What about the horizontal?
It's like the exponent value, right? So it'd be like x squared.
What's the degree? Yeah, what's the degree of the top here? 3, right? What's the degree of the bottom?
2.
2. Based upon that, if the degree on the top is greater than the degree of the bottom, we can do what with it? What will we have for the horizontal?
0 maybe? I can't this one.
This would be actually none. Yeah.
Dang it.
I think it's on the form of the sheet too.
Okay.
I think it's on the form of the sheet.
Wait, so why is it none?
Because the degree of the top is greater than the degree of the bottom.
Oh, yeah.
If it's greater on the bottom than the top, it'd be 0, like y equals 0.
Mhm.
And if it's the same, we divide.
Is that on the homework sheet?
Should be, yes. Again, I have formula sheets over there. Remind me, and I'll try to get you all one. I'll print them out or something in between. So just remind me, we'll get them. All right. Now there's one more thing I didn't put, and this was kind of my fault because I forgot to put it down. Slant, right? Why is there a slant?
One more than
I'll tell you right now that's watching the podcast and y'all, it's a bonus on the test. Okay, it's a bonus. It's one of the last ones. Right there, what I say is very similar to this. I'll tell you to find all of this stuff, but then two of the bonuses, and I'm probably giving you too much information, but it's okay. One of them is find the slant, and another one is graph it. So, if you don't want to just put that down. So, trying to help out. So how do I divide? How do I find the slant? I just said it. Divide it out, right? The bottom end to the top. The reason why is when it's 1 degree higher on the top than the bottom, you divide it out and we'll have a slant asymptote there. So, so this would be x cubed plus 2x squared minus 15x plus 0. And the bottom will go into it. So x squared plus 8x plus 15. So x squared goes into x cubed, or what times x squared gets me x cubed? You remember this part?
Oh, x.
X, right? By the way, this is important, not just for slant, but also long division as well, okay? So just be sure you get that there. So x times x squared, and then we just multiply it out, right? So you get x to the third plus 8x squared plus 15x. And what do we do with all three of these? Change the sign, right? Is everyone okay with this so far? Cancel. 2x squared minus 8x squared gets me negative 6x squared. And negative 15x minus 15x is negative 30x. Now you could bring down the 0, but remember, I don't care about a remainder. So all I need is the next number. Once I find the next number, I'm fine. I don't need to even go any further. So what times x squared gets me negative 6x squared? Negative 6, good. So I could stop there. I don't even have to go any further, right? So my slant asymptote's y equals x minus 6. And then we'll go from there. Does everyone know how to graph that? Is everyone good with that? So if I were doing, it's just like a line, right? Negative 6 is representative of what? Y-intercept. Yeah, so we start at 3, 4, 5, 6, boom. And what's my rise over run? Up 1 over 1, and then you just kind of dot. You're good? Okay. And if I was doing this, vertical asymptote would be here. Okay? How do I know where I graph it? I can make a T-chart both to the right and to the left to see where it is. So like if it's down here, I know the graph will look something like this and kind of go like that. Okay? Got me? Also, if I asked you to find the x and y intercepts of that, could you do that? Yeah, so y-intercept, we plug what? Plug 0x. Yeah, that one's easy because this would be like 0 times 0. If 0 times anything, 0, right? So 0's on top. 0 over like 3 would be just 0. So your y-intercept would be 0, 0. Okay. That makes sense? Your x-intercept, you plug 0 equals all this, right? So really, we're just concerned with what the top is equal to 0 there. So what two x-intercepts would you have? Could that make sense, what I just said?
Sort of. You only do it on the top.
Yeah, so like if I said 0 equals that, it's only the top because you can't have 0 on the bottom. We can't have that, right? It's undefined. Yeah. But on the top, that's what makes it like equal 0 over here, right?
Yeah.
So this would be 0, and then this would be.
So you only do the simplified equation.
Correct. Yeah. Correct. So 0 and 0 and 3, 0 would be your x-intercepts.
Because you do the 3, like the x3, x2, you do that with the full equation, and then you switch. It's just like, and then you use the simplified equation.
Yeah, if you forget that, like if you forget that for the horizontal, you're saying, because that one, like all the other ones use the simplified one, right? If you forget and you're like, oh man, what one do I use that for? Just remember, like, okay, how many x's do I have on the top?
Like all of them?
Yeah, just in the simplified one. We'll keep it simplified.
2.
2, right? How many simplified on the bottom?
1.
Does that change anything?
No.
No, you still do the same exact thing. And oh, by the way, if you end up multiplying x times x minus 3, and saying x plus 3 goes into the top how many times, you get the same thing for your slant as you did over here. So if that confuses you. All right. Unit 2, any other questions? I love it. I love it. Would you mind taking just a quick breather? JT has been with me for a couple study sessions, and he has had a question on a, can we go over that one we were talking about? We're going to go over Unit 4. You probably have it too. Pascal's triangle. Y'all have a question on that too?
Juicy.
It's a juicy one. Is that on your list? So if you're looking at it, we're gonna do one like number 3, and we're also gonna do one like number 5. Okay. And by the time we get through that, we will be done, and we'll go over across the way. Okay. I think this class ends at what, 2:15 or something? Yeah. Perfect. Gives us 10 minutes. Perfect. Okay.
Whereas are like hit and miss though.
Say again. So we got about 8 minutes left. That's perfect. We can do this in about 8 minutes. That's good. All right, I'm gonna change this problem up. I know that I could go to one of these, but I've already done these with JT, and so I'm gonna make some new ones up because I think that'll be helpful. Okay. Let's say 2x minus 3y is to the 6th power, and I want you to find the third term. Okay. That's problem 1. Problem 2 we're gonna look at is let's say x minus, let's say 2x minus y to the 4th power. I want you to expand that. So in both circumstances, you're going to use Pascal's triangle. You know, by the way, you'll have that for your formula sheet. Okay. So in the 6th one, Pascal's triangle follows the following pattern: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, and just so on and so forth. Now, something important to note. Notice the amount of terms you have will always be 1 greater than your highest exponent. Okay? Meaning that if you have this, which is to the 7th power, I'm sorry, to the 6th power, how many terms will it have? 7. Does that make sense? So that's just something to keep there, okay? So as I look at this, up here on this one, I'm not looking at 2x and 3y yet, okay? All I'm going to do is I'm going to look at this row, because that right there has 7 terms because, again, it's 1 greater than the power we have. Now, as I rewrite this, the variables are very important. In fact, I'd use a lot of paper for this one. So what we're going to do is we're going to have 2 variables. We're going to have x and we're going to have y, okay? X is going to decrease from left to right. So this will be, I'll put it over here. 1, x to the 6th, 6, x to the 5th, 15, what's going to happen? X to the 4th, good. 20, x to the 3rd, 15x squared, 6x, and then just 1, okay? Now as x decreases, what's going to happen with y? It increases. Notice that the sum of the exponents will always be equal to the power, original power, okay? So that means this has no y. The next one has 1y, y squared, y to the 3rd, y to the 4th, y to the 5th, and y to the 6th, right? Okay? Now, how many terms do I need? What term am I looking for? There are 7. You're right. You're just looking for the 3rd. You don't need to expand it. You could, but we only need to expand. We only need that 3rd term. So I'm going to pull that one out. Okay? So this is 15 x to the 4th y. Now, what goes in for x? It's not just x. What goes in for x?
2.
Wait, that one's y squared.
3.
Y squared. I'm sorry. Thank you very much, Cam. Apologize right here, just in case you're seeing at home. Okay. What did we do? What did we plug in for x? I heard.
2x minus 3y.
Yeah. So 2x
yeah.
is the first term that goes in for x.
Oh, okay.
Does that make sense? So JT, does that make sense so far? Okay. Does it make sense how I got this number? Does everyone get that so far? You got that. That's like the hardest part. Basically, x. What confuses you, or what confuses a lot of people, is that what x are we using? That doesn't make sense. What this represents is the first term. Got me? That's all. So it means that whatever I plug in for this one is the first value, which happens to be 2x up here. Does that make sense? So it should look like this. We'll put 15 times 2x to what power? To the fourth, good. And thanks to Kalen, we know that the next one is what? Negative 3y, and it's going to be the what power? The second. Okay? So let's do it step by step here. Let's go to the powers first. 2 to the fourth gets me what? Because these both have to go in, right? So does the 2 there?
16.
16, good. X to the what? X to the fourth. And what about this negative 3y? What does that change to?
9.
9 y to the
Square.
second. Good. 9y squared. Okay? So literally, we'll take 15, multiply by 16, multiply by 9 to get what our coefficient is, and then we just include x to the fourth and y squared at the very end. Okay? What are you thinking? That make better sense there, JT? Okay? So if you can get that, that would be, again, that's the idea.
After we plug in 15, multiplied it, do we just leave it?
Like 15 times 16 times 9. Yeah, whatever number you got, coefficient, we just put x to the fourth y squared next to it. Okay?
But do you multiply all those together, or do you just do 15 times 16, 15 times 9?
It's not distributing because this acts all as one, right?
Okay.
Like up here, this acts all as one.
So you
So
just
it's
all multiply them?
perfect. 15 times 16 times 9. That's a really, really good question. Okay?
They do x for y2.
Say again.
Like you.
You leave x to the fourth y squared. Now on that one up above, I think it just says find the coefficient, so you don't have to include it with it. But if you did, I wouldn't count off. Okay?
This isn't multiple choice, right, baby?
This is not, and you don't want it to be multiple choice. And I want to make sure of that. If you have any idea of what you're doing, multiple choice usually will decrease your grade. So no multiple choice there. All right, so 2x minus y to the fourth is okay if I turn in like overdrive. I've got like 3 minutes, 2 minutes, okay? All right, so let's do this. Let's go 2x minus y to the fourth. Okay, so this one, I'm going to use y. How many terms does it have?
Oh, yeah, 5.
5 because it's 1 greater than my exponent, right? So this one would be x to the fourth, x to the third, x squared, and x. What happens with y's from left to right? Increase, right? So none, y, y squared, y to the third, and y to the fourth, okay? So far, so good? Okay? So now, from this standpoint, what goes in for x in each one of them?
2. Yeah.
2x, good, yeah. So really, and I know this can be really small, so just work with me. 2x to the fourth we're going to take, right? Well, I'll actually rewrite it. So 2x to the fourth plus 4 times 2x to the third, and then negative y goes in for y, right? So we'll put negative y in. That x is 1, okay? Next one is plus 6, 2x to the second, negative y to the second, plus 4 times 2x times negative y to the third, and then plus negative y to the fourth. Now that seems like a whole lot, and it is, okay? And it is. But each one of these aren't difficult in and of themselves. So once I spread them out, just take each one. So what would this be? We did this one earlier.
Yes.
16x to the fourth, right? What about 2 to the third?
8.
8, right? 8 times 4 is 32. X to the third, right? What happens with y? Just put it in, right? But what happens with the sign?
Negative.
Turns into negative. Here's a hint. Whenever there's like something that's negative there, it will always go back and forth. Positive, negative, or negative, positive, negative, positive. All right, always back and forth. All right, so now the next one. What's 2 to the second?
4.
Times 6?
24.
24. Good. X squared and y to the second, right? And again, that's positive because it's even, right? Again, it goes back and forth, right? Next one, 2 times 8, or 2 times 4, obviously. 8x, y to the third. What's wrong with this picture?
Negative. These two negatives.
It's got to be negative because it always goes back and forth, right? Last one, what would be the last one here?
24.
1/4, and that would be my answer. Okay?
Would that be negative 1 to the 4th? Or no, never mind.
Because it's even, right? Does that make sense? So it always goes back and forth, so you can check yourself on it. Okay? All right, I am going to pause this. That was part 1 of the podcast. I may try to do the part 2 here, but have a great day, and we'll see you.